Okay, so our next section is about inscribed angles, and I definitely want to warn you, inscribed angles are going to be used a lot in this unit, and so I want to do a lot of examples so you feel comfortable with it and see a lot of different scenarios. I still can't show you all the possible scenarios, so if you need to fast forward through some of these examples, I totally understand, okay? But if you're struggling, then I would suggest you watch more of the examples, if that makes sense, okay? So the first thing we want to talk about is what is an inscribed angle? So by definition, an inscribed angle has its vertex on the circle, okay? And the sides are going to be chords. So here's chord RS and here's chord RQ. And so this makes an inscribed angle, okay? It's inside the circle, but not through the center, if that makes sense, okay? Now it can be. So there's three different scenarios for inscribed, and these are all inscribed, okay? Because you only need your vertex to be on the circle and your two sides of the angle to be chords. So one is if one of my chords goes through the diameter. That is possible, and it's still an inscribed angle. It's not a central angle, okay? Remember, central angle means that both of my sides are radii. So this is central angle. All right. The second one is what we have shown here. The two sides are just chords, and then the third side, the center doesn't even have to be inside my angle at all. This is an inscribed angle, all right? So the inscribed angle theorem says if an angle is inscribed in a circle, then the measure of the angle is half of the arc. So in a central angle, remember, if this was 40 degrees, my arc was 40. On this, if this is a 100-degree arc, my inscribed angle that's covered by that same arc, so you always want to go to the endpoints. Like if I was extending this angle, it would reach the arc between it, and that's going to be half. So half of 100 means that angle 1 is 50 degrees, okay? And so this is huge. We can do triangles, quadrilaterals, different shapes, a few shapes inside, but this will get used a lot. All right, okay. So the inscribed angle theorem, for some reason I have it again. Okay, well, I'll take that out on your notes. So let's do a few examples. So I've got two for this diagram. So we want to find the measure of angle P. So when angle P is not written with three letters, it's talking about the arc that's made from the inscribed angle. So I would prefer it to say, find the measure of angle MPN. That's better. But we could say angle P because that's the only angle that's created around P. So what we need to do is if I extend this, and I like to do it to help, this is the arc MN that's related to it. And so if that arc is 70, I know half of that is 35. And if you're doing this on paper, I would go ahead and just label it because you might use that information for other parts of a question. All right, part B, we want the measure of arc PO. So arc PO is right here. Okay, and so what I notice is these are the endpoints, and I have this angle. Let's see if we can get a color. I have this angle right here. Oh, my color went away, but that's okay. And so if this arc is half, the angle is half the arc, that means I'm going to double it to get the arc. Okay, so the angle is half of the arc, or the arc is 2 times the angle. You can think of it either way. So 56 times 2 is 112. Okay. All right, a new drawing for new questions. So we want arc CF. So C to F. And so I know I'm stopping at C and F. And so if I look at this angle, it also, my two sides are going through C and F. So if the angle is 40, I'm going to double that to get the arc. Okay. And you don't need to show me this work. I totally know you can do that in your head. The measure of angle C, well, same idea. Let me go ahead and get rid of this. All right. Okay. Angle C is going to be this angle, and so I'm going to make it a little more exaggerated. And what I notice is it goes from arc DE, and we know arc DE is 98, so if we take half of that or divide it by 2, I get 98 divided by 2 is 49. All right, and so they might ask you questions like if I had a point here, I could label this as, let's say M, and I could find angle CMD, because now we have a triangle, and we know triangles add up to 180, but you can see how these can get more complicated for sure. All right, so if two inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. That should make sense because if I have angle B, that intercepts arc AD. And so let's say if this was 100, then this would be 50. And same idea, angle ACD, if we extend it, is also intercepting arc AD. So if that's 100, then this is 50. And so it kind of goes both ways. If I know my angles are congruent, then they have to either intercept the same arc or congruent arcs and vice versa. All right. So my example is right there. On this circle, looks pretty complicated. It says find the measure of angle T. So measure means size. So we want a number answer, just so you know, not just the expression. So angle T, what I notice is they tell me that angle T is equal to 3x minus 5. And then I know angle U, but you might say, well, what do we know? I don't know how much that arc is, but I know that angle U is equal to 2x plus 15. Well, they both intercept arc SV, so if they intercept the same arc, that means that these have to be the same measure. And so if angle T has to be the same as angle U, we know that angle T is congruent to angle U, and then by substitution, we can set our expressions equal to each other. So 3x minus 5 has to equal 2x plus 15, and now we have an equation that we can solve. So I can subtract 2x, and so x minus 5 equals 15, add 5, and so x equals 20. The issue is the question doesn't ask for x, it wants to know how big angle T is. So I'm going to put in, wherever I see the x, I'm going to put in 20. So 3 times 20 is 60, 60 minus 5 is 55. And that's how big angle T is, which means angle U is 55. Okay. The other thing we know, let's see if I can get, I really want to change colors. If angle S is 3x and angle V is x plus 16. Well, same thing. If I have angle S, that intercepts arc TU, and angle V also intercepts arc TU. So we know that angle S is congruent to angle V. So 3x equals x plus 16. So if I subtract x, we get 2x equals 16, divide by 2, and so x equals 8. We want to know angle S, so if x is 8, did it again. 3 times 8 is 24, so angle S equals 24 degrees. All right. Thales theorem. He got so famous, he got to name a theorem after himself. But this says that an inscribed angle of a triangle intercepts a diameter or a semicircle if and only if the angle is a right angle. So let's think about that. If I have triangle FGH and one of my sides is FH, well, that's a diameter, right? And so what we know is that a diameter is equal to 180 degrees because it's half of the circle. And this angle intercepts that arc because 180, this whole arc is also 180. And so this is my inscribed angle, which would be half. And so if that's 90 degrees, then we know it is a right triangle. So that's why. All right. So if the inscribed angle has endpoints of the diameter, it's always going to be a right angle because that's half of 180. All right. So let's look at this example. We've got find the measure of angle F. Well, what I know is FH is the diameter. And so this is my right angle. And so I know all three of these angles have to add up to 180. So I get 4x plus 2 plus 9x minus 3 plus my 90 degrees. Those are all three angles of a triangle, and it has to equal 180 total. Okay? So I'm just going to combine like terms. I get 13x. 2 minus 3 plus 90 is 89. So I can subtract 89. So 180 minus 89 is equal to 91. And then those are being multiplied, so I'm going to divide by 13. So x equals 7. Now that's x, so if we want to find f, I'm going to put that in for x. So 4 times 7 is 28. 28 plus 2 means that angle f is 30. So I'm going to go ahead and label that as 30. The angle S is 7x plus 2. So now we're going to talk about the same thing, but they want us to change it. So I'm going to draw my own circle. All right, so F is 7x plus 2. And if angle H is 17x minus 8, find x. So on this one, I know if that's 90, I know that these two together have to add up to 90. So 7x plus 2 plus 17x minus 8, those have to equal 90. So I can use the 180, or I can just say those two angles have to equal 90. Either way. So combine like terms, 17 plus 7 is 24. 2 minus 8 is minus 6. I'm going to add 6. And then those are being multiplied, so we'll divide by 24. We've been solving for a while, so I get x equals 4. And since that's all they want, then we can stop. Okay? All right, let's bring this up. So in the figure below, AB is the diameter, which it looks like it, of a circle of a radius of 17. So I'm just going to highlight that that's 17. Which also means that that's 17. If BC equals 30, what is AC? Well, remember we have a right triangle and we're talking about the sides. So this is the Pythagorean theorem. So A squared plus B squared equals C squared. Remember, the side across from your right angle is the hypotenuse. So I've got x squared plus my other side is 30. And I need this entire length. So 17 plus 17 is 34. And now hypotenuse should be the longest side. So x squared, 30 squared, oops, that's a plus, is 900. 34 squared, I don't know that one, is 1156. Okay, so now we need to solve for x, so I'll subtract 900. So x squared equals 652. We can, to get x squared, we can take the square root on a calculator. Go ahead and see if that comes out nicely so you don't have to break it down, and it does. So x equals 16. Technically, when we take the square root, it's plus and minus, but for lengths, they're always going to be positive. Okay? And so that's what we know. AC equals 16. All right, now we're going to get to some more complicated drawings. So if you've got the basics and you feel confident to try your practice, go for it. Otherwise, you can keep watching. So BC is a diameter. Yep, looks like it. Center A. Find DAB, the angle. So D to A to B. So I'm actually looking for this angle right here. So first you want to locate which angle you're referring to. Okay? All right. Well, we need to use a little bit of information. So I know I've got a triangle here, and I know it's this angle, maybe, is related to this arc. So if I could find the arc, that's a central angle, it will be equal. But we need some more information. So if that goes through the diameter, I know from C to B is 180, but what we do know is if that's 18, so this one is pretty tricky. So what I know is that AD is a radius. I'm going to write radius. And I know that AB is a radius. And so my two radii are going to be equal to each other. Okay? And so we have to go back to triangles. And if we have two sides that are equal, the angles opposite them are going to be equal. So if I know opposite this side is 18, that means opposite this side is also 18. Okay? So that would have been back from unit 7, I believe, or 6. Then we've got this triangle inside here. So we're not going to use the arc yet. If I have the triangle, I know it's 180 minus the 18 will leave me with that third angle. So 180 minus 18 is 144. All right, so I'm going to go ahead and clear up some space. And so that's going to be true. So I can actually write that in. The 144, and then that's 18. Okay. So find the measure of angle BAE. So BA to E, I'm looking for this angle right there. Okay. Well, same idea. If AB is a radius and AE is a radius, that means the sides across from the angles are also congruent. So this side is opposite 26, so this side opposite is also 26. So we have another triangle, 180 minus 26 minus 26. And I don't think that's super obvious, but once you see it once, then you'll see it a bunch more times. That's why I like to do a lot of examples on this section. I know it's a long video. All right, find the measure of angle DAE. So what was it? 128. Okay, so DAE, so D to A to E. So we're looking at this angle right there. So what we need to do is we need to find, if we knew that's a central angle, so if we knew this arc, then we'd be able to find it. Well, we do. So if I look at this arc is across from 144, so there we go. And this angle that we just found was across from 128. And we know a circle altogether, all that's left is this much, and they all have to add up to 360. So 360 minus 144 minus 128 is 88 degrees, which means the angle is 88 degrees because they're central angles. All right, a few more examples. And you can just kind of see I have 4, lots of triangles, lots of arcs, some central, some inscribed. Okay, so let's just try this. It says find the measures of all labeled angles. So we're looking at X and Y. All right, well, what I notice is, oops, there we go. We've got triangles. So first thing is we've got, if these two are the same, it means that my other sides are going to be also the same. So this one is going to be a little tricky, but what we notice is that if this inscribed angle is 28, remember, I know the arc that intercepts is going to be double of that because that's the inscribed angle. So 28 times 2 means that that's 56. Okay, and I know that's not what we want yet. So now we go through and we say, okay, well, if I look at this angle that's inscribed, it's also ending at arc BF. So if its arc is 56, that means across from that is half. Okay, and since these are the same x, I can use that as the same. It's not like if I wanted it to be a different value, then I would have to use a different variable. Okay, so we know x equals 28 degrees. So now we need to find y, and let's go ahead and see if I can get a color. I've got this triangle. So we know triangles add up to 180. So we're going to take off that 74 from the bottom. And then both of these are together. And that will leave us our third angle. So we get 180 minus 74 minus 28 minus 28. So I got the D. Okay. And so notice all the labels in the picture were used eventually. All right, let's look at B. So on B, we want to find just Y. So that's all that's missing. All right, so we've got a lot of information. So the first thing I notice is if this is 14, that's an inscribed angle, so its arc is going to be 28. That might not help us, we don't know. But this arc is also related to this inscribed angle, so if that's intercepting an arc of 28, this angle is 14. And I just start labeling information that I know because it might lead me to where I go, okay? So next thing is we want this side. So I know if I could find this arc, BC, that's going to be double whatever angle Y is. So that's kind of where I'm going to try to go. This 34 is not inscribed, so I can't use that information. But we do know that we don't know a center. But let's get a different color so you can see what I'm trying to show you. I do know we can figure out this triangle right here. Okay, so the 28 is the arc, so you can ignore that, but one angle is 14, one angle is 34, and so I can find this whole missing angle right there from 180. So 180 minus 14 minus 34 is 132. All right, so that angle right in there is 132. And I'm going to go ahead and kind of blow this up. So 132. Now, what we notice, and I'll draw it down here, is that we've got this was 132, and this is angle Y. Okay, which means they're linear. We talked about linear angles. They add up to 180 altogether. So 180 minus 132 will be Y. 180 minus 132 is 48. And there we go. Totally different relationship. All right, let's look at C. So on C, it looks like I'm only finding X. All right. We've got a central angle. I've got 112 right here. Same idea. Well, it just makes a line together. I've got 180 minus 112, 68. These are vertical angles, so if that's 68, this angle right here is 68. Let's see. Well, if we want to find X, I know I have a triangle. I need to find this central angle, but this central angle intercepts arc BC. Well, this angle, which is inscribed, also intercepts arc BC. So if this inscribed angle is 40, that means the arc is 80. And since the arc is 80, the central angle is 80 right there. And so I'm going to draw it over here. We've got this really skinny triangle that has an 80-degree angle here, a 68-degree angle there, and then X. Yay! So take those off of 180. Lots of triangle relationships. So X equals 32. All right, long enough. I know these are a lot of examples. So on D, it looks like we're looking for X and Y. Well, Y is an inscribed angle. X is also, well, it's not even inscribed. But we've got, let's see, if this is 120, the central angle, that means from here to here is also 120. We're just going to write down information that we know. And then Y, which is this angle here, intercepts the other arc. So the other arc, 360 minus that 120, gives me 240. So that whole other arc is 240 degrees. And so the inscribed angle is going to be half of that. So right now we know that Y equals 120 degrees. And then we know if these are both radii, AB and AC. So if my sides are equal and my two angles are equal, then remember that's a quadrilateral, which adds up to 360 as well. So if I take 360 and I take off the 240 that we know, that leaves us with 120 degrees for those two angles. And so consecutive angles are going to be adding up to 180. So divide that by 2 and we get 60 degrees. All right. And so the last thing that we have is, I know if this is 120, this is the inscribed angle, so that's going to be half of it. And then let me get a different color so you can see the quadrilateral that I want you to see. We're talking about this quadrilateral right here. Ignore the lines in the middle. So quadrilaterals, the angles all have to add up to 360. Okay? So I know the top angle is 60. This left angle is 84. This bottom angle is 120. And this bottom angle, part of it is 60. So if we subtract all of that, I'll get what's left. So 360 minus 60 minus 84 minus 120 minus 60. 36. Okay, pretty tough. All right, well, I'm not saying that all of your problems are going to be that difficult, but I'd like to at least show you, and it can even get more complicated than this, a range of difficulty. All right, so go ahead and try your practice and good luck.